Hello and welcome to QED Stata 5 from S31, so the very last part of this. Now it's hard to know what to show you because there are countless ways you could do tests, so I probably will not choose the same one as you. So I'll just show you a couple of examples to get you going. For example, the independent samples t-test is probably the most common one, the workhorse, that and the correlation one. So let's at least have a look at those two. So if we go to the data here, we found previously that if we look at this, is when we're looking at the binary analysis, so in what proportion of cases is there potential to reduce emissions? That's this one here. We found that the proportion of yeses and nos was different depending on whether or not that place gave irrigation water. So I think where it was a nature reserve giving irrigation water, there was more potential for reducing emissions, a higher proportion of yeses than nos. Quite a striking difference. So I'm wondering, is that because there's more carbon locked up in these areas that are producing irrigation water potentially? Or if there's a connection between that and deforestation. So what I'd like to do is I wonder if depending on yes or no for irrigation water, then the value of the mean of the carbon stock, either the mean carbon stock or the total carbon stock could be different. So perhaps let's go for the total carbon stock in that area. We can try both the carbon stock mean and the carbon stock total and see if there's a difference there. So, lost the default, there it is. So you can run a t-test, carbon stock. Okay, let's go for the mean to start with. What would I do without the reminders we get from good old stata? And let's just do the same for tots and see if any of those. Some people think that it's dangerous that it's so easy to do statistics now. You used to have to do it with a calculator. You just bang things in until you get a result that looks interesting and publish it, as Paul will be telling you. So let's just run those two t-tests. So null hypothesis in the first one is going to be that the mean carbon stock locked up in these biodiversity areas, whatever they're called, the mean stock locked up there is the same whether or not they produce irrigation water, and same for the total carbon stock. The alternative in each case will be the let's say it's higher because that's what we had reason to suspect. So the alternative, one side of the alternative, that is higher in the areas of the irrigation water. So let's see if we can run those and see if we get anything that makes sense. Now at this point I must confess I really should have chosen that economics file rather than ecosystems. If Oliver Springate knew I was trying to teach people stuff with ecosystems, he'd be very amused. Hey, we got a significant result. Well, that's good. And of course, there's no favoritism. So against the alternative, it's higher, which presumably is this one. Yeah, so the yes is higher, yeah. Whereas this minus this is going to be negative, yes. So we can very definitely reject the null hypothesis at the 1% significance level. And only just if you look at the total. So what I need to do is read the paper and understand what on earth the difference is between the mean carbon stock and the total carbon stock. It mean nothing to me. That's all these environmental whatever they're talking about. But so reject results, so I'll take that. So we can reject the null hypothesis, and there seems to be a connection, again, evidence of a connection between provision of irrigation water and the carbon stock levels, however measured. So there's quite strong evidence there of a connection. Okay, so that's an independent samples t-test. Another thing we can clearly do is some sort of correlation test, because there are so many numeric variables going on there. And I suppose it would spoil it if I just looked at the big correlation matrix of all these things, because you see straight away which ones are correlated. What's going to be? You think the deforestation rate was going to be? Is that going to be related to? Yeah, perhaps we just look at these two: the flood protection importance, the emittance avoidance, the deforestation rate, and the carbon stock mean. Because I like that one more than the carbon stock total. That wasn't so significant. So we're going to get a nice little correlation, perhaps a matrix to start with of those, and see what it looks like. So work out how I can get you to see. Okay, let's put it down there. That's visible on the screen. I've got this nightmare. I'm going to make 30 videos one day, of which none of it's visible or audible. It'll be a break for you guys anyway. So we're using the same command as we made. It was used where it was here, graph matrix. You just put in the, and we use the same option half there. So we put in the things we think we're interested in seeing, correlation between. So graph matrix of, what was it going to be? Carb stock mean. Yes, we like carb stock mean. And we like deforestation rates. Not like as in they're good, you know what I mean? Net void, that's good. For protection, oh, that's have importance. Enough. 1, 2, 3, 4. Okay, let's see if there's any sign of any sort of correlation between those. Okay, let's tick tock, here we go. Possibly positive there. Flood protection importance of mean carbon, good old carbon stock mean comes up trumps, and deforestation rate, yes. Emit void, oh, I don't think I meant to put that, did I? Emit void val, oh, okay, let's just sort of put emit void val in. I put the binary variable instead of the actual value, so I've got a stupid graph. Great. Oh yes, look, nice. There's some correlations there. Yes. Let's have a. Hey, look, God, I could be an environmental scientist. Blimey, I thought I had no green credentials. All these things here. Where a star? 5. Pretty confident. Yeah. Okay. Carbon stock mean. Oh, it's positive, yes. So carbon stock mean is possibly correlated with the potential for emittance avoidance. Surprise, surprise, a very strong. So you can reject a null hypothesis that it's not correlated at the 1% level easily, and very positively related with flood protection importance. Interesting. I'm going to have to ask one of you guys, why would that be? Why is carbon stock, the mean level of carbon stock, related to the flood protection importance? Is that because of trees, roots holding back the soil and so on? God, I really should get away from it. So I'm just going to show my ignorance about the environment. Emittance void value, that's positively correlated with, they're all correlated. Emittance with deforestation rate. So more, why deforestation rate positive? More potential to avoid it. I suppose they're saying if you stop the deforestation. That's only barely squeaks in at 5%. So this one's very marginal at 5%, but there is a negative correlation between deforestation and flood protection importance as well. And the only one that's not coming out is the flood protection importance and the emittance value. It's not really correlated. Oh, good. Okay, so a couple of significant results there. So I think as we're coming up to 10 minutes, rather than hear me waffling on and exposing my complete lack of expertise in the area of environmental science and ecology, I think we probably better be quiet and wait for the next economics example and leave you to get with running some tests. And please tell me if you find anything that actually means anything in the real world, or if my own conclusions have been not sound. So enjoy exploring the rest of that, and please put any questions in the forums, or send a message to me if you want. We can discuss it in the live sessions, or we can arrange some sort of small group chat or something to go through things if you're stuck. But enjoy that, and thanks for watching.